Hello students, so we have started with the topic probability. Okay, so we are starting with the next subtopic, that is Bernoulli trials. Okay, so this type of trial means what? We are doing some experiment. Okay, so if you are tossing a coin, okay, once, then it becomes a trial. Okay, so you have only two outcomes, that is either it is head or either it is tail. Okay, so like this you can take example for say decision, that is or exam time, that is you are saying that you will pass in this exam or you will fail in this exam. So there are only two outcomes, fail or pass, right? So Bernoulli trials definition is that trials of a random experiment are called Bernoulli trials if they satisfy the following conditions. So there are some conditions for this. Okay, and if those trials satisfy these conditions, then we can say that these are Bernoulli trials. Okay, so in this there is a success, that is we are getting the outcome we want, that becomes the success, and if we are not getting that outcome, then we can say it is a failure. Okay, so success and failure. So first condition is that there should be a finite number of trials. So finite number of trials, that is if we are tossing a coin, then it can be for 3 times or 4 times or 10 times. Okay, not n times or not infinite times. It can be n times. N can be anything, 1 2 3 4. Okay, so it should be finite number of trials. The trials should be independent. Okay, so one trial should be independent of other. So trials should be independent. So the outcome of one trial should not affect the outcome of another trial. Okay, then each trial has exactly two outcomes. So each trial should get exactly two outcomes, that is either success or failure. Okay, then the probability of success remains the same in each trial. So probability of success remains the same in each trial. Okay, let's see one example. Okay, before that, if we get a success, then we denote it by P. Okay, and if we get a failure, that is probability of getting a success is P and getting a failure is Q, and Q we write it as 1 minus P. Okay, so example, 6 balls are drawn successively from a yarn containing 7 red and 9 black balls. Okay, 6 balls are drawn. Tell whether or not the trials of drawing balls are Bernoulli trials when after each draw the ball is replaced. First condition, replaced, and second is not replaced in the yarn. So you have to check for all these conditions first. Okay, so they have given what? 6 balls are drawn, right, successively. So it is finite number of trials. This is done. Okay, then now we are doing the experiment with replacement. Okay, so probability of getting a red ball. Okay, probability of getting a red ball is 7 by total is 16, right? So probability of getting a red ball is 7 by 16. and probability of getting a black ball is 9 by 60. Suppose it is given that success is getting a red ball, then our success probability will be 7 by 16 and failure probability will be 9 by 16. Okay, or if it is given black balls are drawn, okay, then our probability of getting a success will be 9 by 16. Okay, so next is this is okay. So second condition is trials should be independent. So here this probability doesn't affect this. Okay, then success or failure we got. Okay, there are only two outcomes, that is success or failure, and to write P success remains the same in each trial. So if we are taking out a red ball, okay, every time, then this probability of success will remain the same because we are replacing the ball which we have taken out. Okay, so 7 by 60. Now let's look at the second thing, that is not replaced in the yarn. So probability of getting, okay, a red ball will be in the first trial, it will be 7 by 16. Okay, now we are not replacing it, the ball we are not replacing. So for the second trial, this is for the first trial, for the second trial it will be one ball is already drawn, so we have 6 possibilities out of 15, right? Again 2 balls are already drawn, so we are not replacing them, so we have again 5 by 16. Okay, so this is not remaining the same, that is probability of getting a success is not remaining the same, and that's why we can say that this is not a Bernoulli trial. Okay, so to get a Bernoulli trial, the probability of success should remain the same. Next we are going to learn about binomial distribution. Okay, it is given by the formula, that is probability of x successes. Okay, p of x is also denoted by p of x. Okay. N c x q raised to n minus x p raised to x. Okay, where your x is 0, 1 till n. Okay, and q is failure, that is 1 minus p, and p is your success. Okay, this is called the probability function of the binomial distribution. Okay, probability function of binomial distribution. So binomial distribution with n Bernoulli trials, and probability of success in each trial as p is denoted by b n p. Okay, this is n number of trials and p is success. So it is for n Bernoulli trials. This is binomial distributions. Okay, denoted by this symbol. Okay, so we have to use this formula, okay, to solve the problems. Let's start. Okay, here x is random variable, whatever we get, that is in the last topic we have seen that this is a random variable x, and with respect to that we get a probability, right? So that probability is given by this formula, and that is a binomial distribution. Okay, let's solve some problems. So if a fair coin is tossed 10 times, okay, find the probability of getting exactly 6 heads, at least 6 heads, and at the most 6 heads. Now a fair coin is tossed 10 times. So n we have 10. Okay, and now this is a coin. Okay, so getting a head, the probability of getting a head will be half, right? So they have asked for head, that is exactly 6 heads, at least 6 heads, at the most 6 heads. So the probability will be p, that is getting a success, will be half, right? And also your q is 1 minus p, so this is 1 minus half, so it is half. So we have this information. Now we'll use that formula, that is p of x ncx q raised to n minus x p raised to x. Okay, so here we want x, right? So x is this is done for 10 times, so it will start from 0, 1, 2, 3, 4 till 10. Okay, so for now you have to use the conditions which are given in the problem. That is, first is it is given that exactly 6 heads, exactly 6 heads. Okay, so the probability for a random variable will be for 6. Okay, so x is 6. Now substitute here. So n is 10, c 6, q raised to 10 minus 6, p raised to 6. So this will be 10c6 is 10 factorial upon 6 factorial, 10 minus 6 is 4 factorial, into half raised to 4, okay, and half raised to 6. Okay, so this will be 10 factorial, you can write it as 10 into 9 into 8 into 7 upon 6 factorial, and 6 factorial will get cancelled, then 4 into 3 into 2 into half raised to 4 and half raised to 6. So here you can use the laws of exponents, so it gets add up, so it will be half raised to 10. Okay, this you can reduce 3 2 0. Okay, so it will be around, this will be 5 into 3 15 into 2 into 7 upon, this is 1 upon 2 raised to 10, so it is 2 raised to 10, right? So 1 of the this thing goes, so 2 raised to 9 remains, so you have to then calculate. So it comes up to something 105 upon 512. Okay, next thing is you have to find for at least 6 heads, at least. At least 6 heads. Now at least means what? P is, x is your greater than or equal to 6, right? So you have to include p of 0, p of 1, p of 2, p of 3, oh it's greater than, sorry, 6, 7, 8, 9 and 10. Okay, so for each you have to use this formula, that is, this will be x is 6, so 10c6 half raised to 10 minus 6 4, half raised to 6 plus 10c7 half raised to 3 half raised to 5 no 7 plus 10c8 half raised to 4 2 and half raised to 8. Then last one is no, before that 9 is there, no, 10c9 half raised to 1 half raised to 9 and 10c10 half raised to 0 and half raised to 10. Okay, so here you can take out this, that is half raised to 4 plus 6 10. Okay, you can take out that number outside and then you can add up the combination terms. Okay, you have to solve for each and you have to add up. Then there is one more, at the most you have to take less than or equal to 6. Same way you have to do. Okay, let's see one exercise question. A die is thrown 6 times. If getting an odd number is a success. Okay, now this becomes your x, that is random variable. What is the probability of 5 successes? No, this is a success. Yeah, this becomes your p. Okay, sorry. So it becomes your p. What is the probability of 5 successes? At least 5 successes and at the most 5. Okay, so exactly 5 they have given, no? Yeah. So first you have to write what is n, then what is x. X will be for that, yeah. Then trials, a die is thrown 6 times, so n is 6. Okay, so probability of getting a success, that is p, getting an odd number. So whenever a die is thrown, you can get odd number 1, 3 and 5, right? So when I throw a die, I'm going to get probability of getting an odd number will be 3/6. Sorry. So it will be half. Okay, so p is half. So q will be again 1 minus half is half. Okay, so you have to use that formula. Okay, so your random variable, since this is n number of trials is 6, so random variable will be start from 0, 1, 2, 3, 4, 5 and 6. Okay, die is thrown 6 times. Okay, so first thing they have given is 5 successes. So 5 successes means p of x, x will be 5, right? So use that formula, n c x half raised to 6 minus 5 half raised to this will be p raised to x, that is 5. So 6 minus 5 is 1, so we'll get here again 6. Okay, 5 factorial, 6 minus 5 is 1 factorial. So 6 factorial you can split to 6 into 5 factorial, so it will be 6 only, upon 2 into 2 into 2, yeah, you can write it as 2 raised to 6. 2 raised to 6 is 2 into 2 raised to 5. This you can cut. So 3 upon 60 2 raised to 5 is 32. So 3 upon 32. Okay. For at least 5 successes, at least means it is P of x is greater than or equal to 5. So you have to start from P of 5, then P of 6, then P of 7. Only 6 are there. So P of 5 and P of 6. P of 6 we have already done, that is 3 upon 32. Only you have to calculate P of 6. Okay, so this way you can calculate the success or the failure.